In this video, we'll perform a dependent samples t-test, also known as paired samples or matched samples t-test, explaining the logic behind each step of the hypothesis testing process, using a real-world example, so you can confidently apply this statistical method in your own research. Let's consider the following case study, where a statistician wants to investigate the effectiveness of a mindfulness program in reducing perceived stress levels among employees at a technology company. Stress in the workplace is a widespread concern, with negative consequences for both employees and organizations. Mindfulness-based interventions have gained popularity as a potential solution. So, the data was collected from 25 employees who voluntarily participated in an 8-week mindfulness program. Perceived stress levels were measured using the perceived stress scale before the program began and after its completion. This is a small, simulated dataset for demonstration purposes. In a real-world study, you would have a larger sample size. This study uses a paired sample design, where each individual is measured twice. In this case, employees provide stress scores before and after the intervention. A similar approach is known as a matched pairs design that involves pairing different individuals based on shared characteristics. Both designs analyze mean differences using the same statistical method. A paired samples t-test primarily helps to eliminate or reduce the impact of individual differences or variability between subjects. This type of variability is a major source of error in many research studies. It addresses a type of error known as confounding due to individual differences. This occurs when the characteristics of the individuals in your sample influence both the outcome variable and the independent variable you are studying. The confounding variables like the baseline stress level, the external events happening during the study period, and the personality traits of an individual could influence both stress perception and willingness to try mindfulness. A paired t-test controls for these variations by comparing each person's stress level change, by assuming these events affect both pre- and post-intervention measurements similarly for each individual. Now, we'll conduct a paired samples t-test using a 5-step hypothesis testing approach. We'll begin by formulating null and alternative hypotheses. Then, we'll verify that the data meets certain statistical assumptions, and once assumptions are confirmed, we'll compute the test statistic and use it to find the p-value. Finally, we'll make a decision about the null hypothesis based on this p-value and interpret our findings in the context of the study. A null hypothesis is defined as a statement of zero or no change. This means the null hypothesis assumes that the mindfulness program has no effect on stress levels. Any observed difference in stress levels before and after the program is due to chance or random variation. In statistical terms, there is no significant difference in the mean perceived stress levels of employees before and after participating in the mindfulness program. An alternative hypothesis is defined as the statement that is true if the null hypothesis is false. This suggests that the mindfulness program has a significant effect, leading to a reduction in perceived stress levels. In statistical terms, there is a significant decrease in the mean perceived stress levels of employees after participating in the mindfulness program. This is a left-tailed test because the alternative hypothesis includes the less than sign. To perform the hypothesis test, the following statistical assumptions should be met. The assumption of independence within each pair can be assumed if participants were randomly assigned to the intervention and there are no carryover effects between the pre- and post-test measurements. The normality assumption states that the differences in stress scores between the pre- and post-intervention measurements should be approximately normally distributed. This can be done by visually inspecting the sample data using a box plot, histogram, or a QQ plot, or by conducting the Shapiro-Wilk normality test. To visually assess the normality of the different scores and check for outliers, I created a box plot in RStudio. The box plot's median line is centered within the box, suggesting a roughly symmetrical distribution. And no data points fall outside the whiskers, indicating an absence of outliers. To calculate the test statistic, use the following formula, where D is the difference between the pre- and post-stress level measurements. D bar is the sample mean of differences. SD is the sample standard deviation of differences. N is the sample size. First, calculate the difference between pre- and post-stress level measurements for each pair. Then, use the following formula to calculate the sample mean and sample standard deviation of the differences and put these values in the t-statistic formula. We compute the test statistic, t equals 18.65. For a paired samples t-test, the t-statistic follows a t-distribution with n-1 degrees of freedom, that is 25-1 is equal to 24, and the p-value lies on the left tail of the t-distribution because the alternative hypothesis is left-tailed. In the t-distribution plot, the area under the curve, on the left side of the t-value of -18.65 represents the p-value. In the t-distribution table, first, select a row for the degrees of freedom value of 24. Then select the cells within which the absolute value of the t-statistic 18.65 lies. The header column associated with these cells provides the range of the p-value. The p-value is less than 0.005. Now, the p-value approach will be used to make a decision regarding the null hypothesis, which states to reject the null hypothesis if the p-value is less than the significance level. Since the p-value is less than the predefined significance level of 0.05, we reject the null hypothesis. The results of the paired samples t-test reveal a statistically significant decrease in perceived stress levels among employees following participation in the 8-week mindfulness program. This finding supports the hypothesis that mindfulness interventions can effectively reduce stress in the workplace. The observed reduction in stress levels has important implications for both individual well-being and organizational productivity.